Okay, in the last class, we discussed that how we represent vectors, and then we generally in a bird eye view discussed how to find resultant of vectors. So if one vector can do one thing and the second vector can do another thing, a resultant of the vectors will be one vector that can do what other vectors are doing together. Like if two or three vectors are doing something individually, resultant of those two, three vectors will be one vector that can do the same thing alone. Okay? This is basic definition or the basic understanding of a resultant of vector. Now we have two vectors here. This is vector one, I will call it vector A, another vector B. So we want to see the result of these two vectors. First of all, we have to shift the vectors. And when we are shifting vectors, you have to be very much careful that we do not change the length of the vector, we do not change the direction of the vector. These are the two things you have to be very careful. And second thing is when you are finding resultant, you have to connect the vectors in a very specific order, that the second vector should start where the first vector ends. And third vector should start where the second vector ends. So all of the vectors should be connected one after the other. This arrangement is called head to tail arrangement. We have to connect vectors like the second vector, the next vector start from the finish of the previous vector. Let me show you what I'm trying to say over here. For example, we have A and B vectors like this. I redraw vector A, but when I'm redrawing it, I have to be very much careful that I do not change the length of the vector, neither I should change uh, direction of the vector. We should not change the magnitude of the vector, not the direction of the vector. So we can shift a vector and repeat a vector as many times as we want to, but be careful that do not change the size or the direction. Now, what will be the resultant of these two vectors now? It will
From
start,
the
yes,
tail, no, from the head to the tail of B. From the head of A
no,
to the
no,
tail of B.
no. Listen. The A is doing something. What A did is A shifted a thing from here to here. Okay. Let's say this is point one, this is point two. So A shifted the object from one to two, and B shifted it from two to three. So overall, object has gone from one to three. The resultant of a vector will be a single vector that can shift it from one to three. So it should start from the tail of A and end at head of B.
Was saying the same thing, sir.
Tail of A to the head of B.
सर मैं भी यही बोल रहा था आपको.
Okay. I thought you said from the head of tail of B to the head of A. So this will be the resultant. Good. This is resultant of A and B. इसको यूं भी लिखा जा सकता है और इसको R equals to A plus B. Okay. They both are equally good. Now, what if we have factors? No problem. Draw the first vector, draw the second vector, draw the third vector, and the resultant will be vector. The resultant will be from the tail of the first to the head of the last. Okay, regardless of the order of the vectors, like if it is 1 plus 2 plus 3, if you make it 2 plus 3 plus 1, or 1 plus 3 plus 2, or 3 plus 2 plus 1, or any other order. Okay, so the resultant will be same. It is completely independent of the order of the vectors. Now, what is the opposite of adding vectors?
Subtracting vector.
Resolving vectors. Splitting vectors into components. Finding the possible vectors that can add up to vector that we are dealing with. For example, if we have a vector like this, this is a vector V. So if this is a starting point, and this is the end point, let's call it start point. The tail of the vector is always the start point, and this is the end point of the vector. The head is the end point of the vector. Now, if this is right, this is left, this is up, and this is down. For the reference of your screen right now, along the bottom of the screen is down, along the top of the screen is up, towards right is right, towards left is left. Now, look at the vector and look at the start point and end point. Tell me, what are the influences of these vectors? If I say that it starts from the tail and ends at the head, what do you think? The vector is generally pointing towards right or left? Or is it pointing up and down? If you have to select any two directions out of these four,
Upright.
up, right, left, down, what will be the two directions that will define this vector?
Upright.
Good, up and right. So it means it should have an effect, a horizontal effect towards right. This will be the horizontal effect of the same vector. And this will be the vertical effect of the same vector. Does this make sense? Okay, now, look. This is, there are many ways of saying what vector this is. This is adjacent component, because I will be considering this angle as the base angle. Adjacent component, horizontal component, X component. Like, it depends on the situation that we are talking about. If we are doing a graph on Cartesian plane where x-axis and the y-axis are there, we can say it is X component. If we are doing it in a horizontal vertical plane, then we can say it is horizontal. And if there is no other reference, sometimes we will be dealing with situations where there is an inclined plane and the x-axis now become parallel to the x-axis, or actually the inclined plane. Then there is no way of calling what component is that. It is not neither horizontal nor it is an X component. In that case, we can say it is the adjacent component. So this side, this blue component, is the adjacent component or horizontal component. What about this one? This is
Perpendicular.
perpendicular component. This is opposite component. This is vertical component, or we can also say it is Y component. So the names are always names, they always depend on the angle that we are talking about. All these names are based on this angle. The side that is in front of the theta is opposite component, and side that is connected to theta is adjacent component. Now, if V is the vector here, how can we find this one in terms of V and theta? Now, try to go back down the graveyard of your memory, okay, and fetch an information for a right angled triangle where we connect base and hypotenuse. What is the
So
relationship between base and hypotenuse?
the cos theta is equals to base over hypotenuse.
So base over hypotenuse equals to cos theta. So in this case, it will be, let's call it V's x component. So do you think it is right to say that Vx over V equals to cos theta? So Vx equals to V cos theta. And if we go and fetch a relationship between Fy and Vy and V, what is the relationship between Vy and V? Vy over V equals to sine theta. So Vy will be V sine theta. But in exam, we won't have time to think about sine theta and cos theta and perpendicular and base. So remember this thing. Wherever you're finding a component, the component that is in front of the angle, component that is in front of the angle is always the sine component. Vy equals to V sine theta. And the one that is connected to angle is always the cos component. So Vx equals to V cos theta. We won't have time to establish a relationship between sine, cos, and tan, and perpendicular, hypotenuse, and base. That will be time consuming and very confusing sometimes. This is the shortcut method. Whenever we are finding a component which is in front of the theta that we have taken as the base angle, we are finding the sine component. And whenever we are taking the part of the vector which is adjacent with the angle, which is connected with the angle, that will be the cos component of the same angle. Now, how is this helpful? Okay, you people very like very nice students. You listen to me very carefully, and you simply did not ask any question that is it possible to draw that many graphs and angles and lengths with high precision? And when we are doing an exam where we are judged with not only with the knowledge, but with a very restricted time, a time that is decided very smartly. There's no extra time in paper. So do you think when we are in that kind of mindset, and we have to find out or solve so many questions in this restricted time, will it be possible for somebody to measure the angles with so much accuracy, draw the length with accurate precision, and then find the resultant? Okay, it is a very fancy way of doing it, but I will never recommend you to do that. If you have a choice, get away from this method. This is not the right method. Okay, let me show you what is the right and easier method and more accurate, because in this case, You don't have to measure anything. Everything has to be done by a calculator. Using components to find resultant. See, if we have two vectors like this, and as we have already done, we can connect them from head to tail. And the resultant can very easily be drawn over here. Now, but look, do you think this will be the A's X component and this will be A's Y component? Similarly, this will be B's X component and this will be B's Y component. Don't forget, there is a resultant as well. Now, this is resultant. Do you think this will be resultant's X component and this red one upward is resultant's Y component? Pay attention over here. This is resultant. Now, if you pay attention, you can clearly see resultant's X component is simply the sum of A's X component plus B's X component. Look, this is A's X component. This is B's X component. If we add them, it becomes resultant's X component. Look, resultant's X component is the simple sum of AX and BX. And one more thing, although in vectors, directions are very important, but when we are dealing with vectors that are in the same direction or in an exact opposite direction, we can simply add them and subtract them like scalars. If two vectors are in the same direction, 3 and 2, then we don't bother about their direction. The resultant will be 5. That we can add them like scalars. If vectors are in the same direction, we can add them like scalars. Now, similarly, you can see that this is B's Y component, this is A's Y component, and this is resultant's Y component, which is simple sum of these two. If we have resultant's Y component and resultant's X component, can we use this information to find resultant? No. Resultant X equals to AX plus BX, resultant Y equals to AY plus BY. So resultant will be Rx square plus Ry square root. So if there is a resultant like this, and you know the resultant X component and you know the resultant Y component, you have resultant's X component, resultant's Y component, and you need resultant, and it is a right angle triangle. Pythagorean theorem comes in, which says the resultant square equals to result X square plus Y square. So if we take square root on both sides, we can cancel square root and square on one side. So resultant will be equal to resultant's x component square plus resultant's y component square root. But because it is a vector, we also need direction. So what will be the direction of this thing? This is theta. So theta will be tan inverse of resultant's y component over resultant's x component. Okay, this is a way that only requires a calculator. You don't need a scale diagram for this one. Okay, resultants x and resultants y component, and we can use them to find the resultant. How do we subtract vectors? To subtract a vector, we simply add opposite of that vector. See, if we have A and B like this, and somebody needs B minus A. What do you need? B minus A. So what we do is we take a vector, we find a vector which is equal in size as A, but in exact opposite direction. Okay. Now this will be minus A. In order to find B minus A, what we will do? We will add minus B, minus A to B. See, this is what we will do. This is no. This will be B and minus A, and this one from here to here will be the resultant of B and minus A, which will be arrowheads are very important because these are vector quantities.
सर की ऑफिस से लाइट गई लगता है आज।